friends, today we are gonna analyze You Only Look Once paper by Redmon. So what I'm trying to do with this channel, I'm having difficulty with finding the best explanation of the papers. YouTubers, bloggers always try to say something, but they memorize, they grab the result from the papers and that's it. We don't understand how it works. So what I'm trying to do here, I'm trying to explain how the papers works, how they design it. In addition to understand what, I want to understand why. Instead, we frame object detection as a regression problem to specially separated bounding boxes and associated class probabilities evaluation. They don't do bag of words to train the convolutional neural network. The convolutional neural network learn from the whole image. So they change the detection system as a regression problem. YOLO is refreshing simple. See figure 1. A single network is simultaneously predicts multiple bounding boxes and class probabilities for those boxes. YOLO trains on full images and direct optimizes detection performance. Unlike sliding window and region proposal techniques, YOLO sees the entire image during training and test time. So it is implicitly encodes contextual information about classes as well as their appearances. I want to come the main explanation. Our system divides the image into an S by S grid. What is S by S grid? You all know it, but something like that. Yes. It can be 7 by 7, 13 by 13, 19 by 19. It depends on your application or your preferences. So what I was trying to say, so they use those grids as an initializing point for detection and localization. If the center of object falls into a grid cell, then that grid cell is responsible for detecting that object. So that's a rule that authors put there. And in the next versions, YoloV version 1 we are discussing today, in the next versions they will change a little bit. They will add anchors. But we don't care right now. Each grid cell predicts B bounding boxes. So B usually is 2. In the same grid, only 2 objects can exist. It can be more, of course, but usually, maybe 99.9%, that grid will contains only two objects. As you can see here, some grids contains only one object, but some grids contain 2 objects, dog and bicycle. Some grids has that information. These confidence scores and also confidence scores for those boxes. So those confidence scores reflect how confident the model is that box contains as an object, and also how accurate it thinks the box is that it predicts. Formally, we define confidence scores as probability of object times intersection of union with truth and prediction. Is object really exist there? Is any object, or it is a background? If it is a background, it will be 0. Each bounding box consists of 5 predictions: X, Y, V, W, H, and confidence. At test time, we multiply the conditional class probabilities and individual box confidence predictions, as seen in this equation, which give us class-specific confidence scores for each box. Class-specific confidence scores. That's also important. We have confidence scores for an object and also class-specific confidence scores for each box. Figure 1 model. Our system models detection as a regression problem. It divides the image into an S by S grid. For each grid cell predicts B bounding boxes. We already see that. Confidence for those boxes and C class probabilities. And also if there exist, we need to have C class probabilities. A vector. It's kind of a vector containing C numbers. These predictions are encoded as an S by S. S by S is the grid number times B is the each grid is responsible to generate B number of boxes. It is 2 times 5. 5 means XY, the center of the object, height and width, plus C. C is class specific probability. So this, for evaluating YOLO on Pascal data, we use, and authors use S equals 7, B equal 2. Until now, it gets around 13,000 citations, this paper. Our final prediction label is 7 by 7 times 30 tensor. The label is very different than object. This is also important. We optimize for the loss function. We optimize for sum squared error in the output of our model. We use sum squared error because it is easy to optimize it. However, it does not perfectly align with our goal of maximizing object precision. This is important. It weights localization error equally with classification error, which may not be ideal. So it penalizes localization and classification error differently. This equation is the loss function. I want to emphasize that why it differs with the other methods. It has conceptually 3 parts. Coordinate localization error. This is the first part as a regression model. Localization error. This is the first. As I mentioned, this part is telling us whether or not the grid says, for example, I from 0 until S square. So it visits all grids and sum of J is equal to 0 until B. B is the number of boxes that each grid will generate. And also it is summing the probability, class specific probability values here in the third one. It's classification error. From I is equal 0 to S square for each grid, and for each class it is calculating the mean square error, a kind of mean square, let's say mean square error for of the probabilities, confidence scores to be an object or not, to be that specific class or not. If the first symbol here, it looks like 1. So it is kind of a logical gate, 1 or 0. If it is 0, that means that grid cell does not contain any object. Or if it is 1, it means that contains an object. So 0 or 1, it's a binary logic gate. So this one will explain us why it is good. For example, in this table, the last row, look at last row, YOLO. Mean average precision is 66.4, whereas frame per second is 21. And compare with the third from the last row, faster RCN and VGG 16. Mean average precision is 73.2, much more than YOLO. But the frame per second is 7. So authors trying to come up with an idea that is faster than the other methods, but it may lag with the accuracy. Version 1 works like that, but version 2, version 3, version 4, version 5, we will see in our next videos how they work. I hope you enjoy and you learn something new in this video, and keep in touch, and please subscribe to my channel and give a like and comment, so this good stuff will be recommended to other people. Thank you and talk to you soon. Bye.